HonAlg2 notes Chapter 1, Section 3, Solving Equations. You should have done this in Algebra 1. So here's a warm-up. We're going to solve 0.2 times quantity x plus 3 minus 4 times the quantity 2x minus 3 equals 3.4. Well, you should remember distributive property. We'll do that first. 0.2x, 3 times 0.2 is 0.6, so plus 0.6. Distribute the negative 4 to the grouping. Negative 8x, negative times negative is positive, so this would be plus 12, equals 3.4. Combine like terms on the same side. Negative 7.8x, add 12.6 equals 3.4. Combine like terms on opposite sides. I've got constants here. Negative 7.8x equals, remember you have to do opposite operations, so I'm going to subtract 12.6 from 3.4, and I get negative 9.2. And finally, we divide. X equals, negative over negative is positive, so I've got a 9.2 over 7.8. And I'm going to actually multiply this by 10 over 10 to get rid of these decimals. So x equals 92 over 78. And since these are both even, I can simplify that and get x is equal to 46 over 39. Please always give me fractions, even if they are improper fractions like this one. I don't want to mix numbers, and I'm not a fan of decimals. So give me the exact answer, 46/39. Or, instead of multiplying by 10 over 10 here at the last step, you could have multiplied the equation by 10. Now remember, if I copy this 0.2 times quantity x plus 3, subtract 4 times quantity 2x, subtract 3 equals 3.4. I really have 3 terms here. I've got this term, and then of course this is a negative sign, so I'll just box this up so you can see the terms, that term and this term. And I'm going to take 10 and multiply through to all 3 of these terms. Now remember, and it's important to know, that you can't multiply the 10 with the 0.2 and the x and the 3. This is one term. You just multiply it just one time. And when we do that, we get 2 times the quantity x plus 3. Subtract 4 times 10 is 40 times the quantity 2x, subtract 3. And then 10 times 3.4 is 34. So that gets rid of the decimals for us, so we don't have to work with them. Now we can distribute. 2x, add 6, subtract 80x, add 120, equals 34. Combine like terms on the same sides. Negative 78x, add 126, equals 34. Subtract 126, I get negative 78x, equals negative 92. Divide, x equals 92 over 78, which is what we saw over here. And then, of course, simplify. X equals 46 over 39. So either way, you get the same answer. You just have to be really careful when you multiply through by a number to get rid of those decimals. And I chose a 10 because these were all tenths, 2 tenths. So I multiply by 10 and move and slide that decimal one place over to the right. Okay, how do we solve these kinds of problems? Well, I've got unlike denominators, so I can't add them. So I need a common denominator. least common denominator. What is the least or the smallest number that 2, 5, and 3 all divide? And you say 30. 30 is the least common denominator. It has to be. 2, 5, and 3 are all prime numbers. And so the only, I can't make the 2 be a 5, I can't make the 5 be a 3, and so on. So I have to go with a bigger number, but still the smallest number that all three of them divide is 30. So I'm going to take this whole equation and multiply through by 30. So when I do that, I get 30x over 2 plus 30x over 5 plus 30x over 3 equals, of course, 30 times 31 is what, 930? Let me get a calculator to double check. So turn my calculator on if you're not sure. 30 multiplied with 31 is 930. 930. Okay, now we're going to divide. Okay, 30 over 2 is 15. This is 15x. 5 goes into 30 6 times, so this is plus 6x. 3 goes into 30 10 times, so this is 10x equals 930. All right, we're going to add these up. 15 and 10 is 25, plus 6 more is 31. X equals 930. Again, take your calculator, do 930 divided by 31, and you see that x equals 30. Probably a coincidence that x equals 30 and 30 was my least common denominator, but either way, that is what x is. And you can check these. You substitute the 30 back in, and we could do that quickly. Check 30. We said x is 30, so I'm just substituting a 30 in for x. 30 over 2 plus 30 over 5 plus 30 over 3. Does that equal 31? Well, we look here. This is 15 plus 6 plus 10 equals 31. And yes, 31 equals 31. So I have checked and verified that my solution works. Next problem. Well, the biggest thing here is sometimes students get confused with the grouping, so make sure that you're doing the inside grouping before outside. These brackets are just another set of parentheses, if you will. They're grouping symbols. So I can't do anything with those outside ones first. I got to take care of this, and I also have to take care of this using the distributive property. So this would be negative 14x. Subtract. You can replace this with a parenthesis if you want to. And now here's where I'm going to distribute. This is negative 8x, subtract 2, don't forget about the subtract 7, equals, not doing anything with the 2 yet, I'm distributing the negative 3, so I'm going to negative 3x, add 15, and now I'm going to, actually I'm going to combine like terms in here first because it's easier. Negative 14x, subtract, negative 8x, negative 2 subtract 7 is negative 9 equals, over here I can just full on distribute it because I don't have like terms to combine here. Negative 6x plus 30. Okay, now here I'm only distributing a negative, so be careful. Don't be trying to multiply the 14 here. It's the negative. It's really a negative 1 that gets distributed. Negative 14x, add 8x, add 9. Equals negative 6x plus 30. Okay, combine like terms on the same side. This is negative 6x, add 9, excuse me, equals negative 6x, add 30. If I add 6x to both sides, guess what? The x is going away. And I end up with a statement that says 9 equals 30. Now, when that happens, you have to ask yourself, is this true or is this false? You say it's false. And when that happens and the statement is false, that means there's no solution. If this were to be a true statement, then all real numbers would be solutions. So you might want to put that in your notes. If this would be true, then all real numbers are solutions. Okay, but in this case, that happened to be false, so there are no solutions. If you have questions about that, then please ask. Okay, on to side 2. Example 3 says find 4 consecutive even integers whose sum is 324. 4 consecutive even integers whose sum is 324. Well, first of all, you have to know what consecutive even integers are. Consecutive is one right after the other. You know, like 2, 4, 6, 8. So, for example, 4 consecutive even integers could be 2, 4, 6, and 8. But if I look at 2, 4, 6, 8, and I add them up, that's only going to give me what? 4 and 6 is 10, plus 8 more is 18, plus 2 more is 20. That does not equal that. And so we have to model it. We have to model it with algebra. We don't know what the first number is, so call it x. We do know that the second number in the set of 4 consecutive even integers is increased by 2. So the next number must be x plus 2 in terms of an algebraic expression. If we compare the first, x, to the third, 6, well, how do I get from 2 to 6? I'm going to add 4. So this is x plus 4. Okay, so it's x, x plus 2, x plus 4, and the last one, what do you think it is? If you said x plus 6, you are correct. So this is what I'm going to use to build my, sorry about that little glitch there. I'm not sure what happened with the document camera. Anyway, this is what I'm going to use to build my equation. So it's these 4 numbers whose sum, which means I'm going to take these 4 numbers and add them, means equals 324. So I say x plus 2 plus x plus 4 plus x plus 6 equals 324. And now I have a nice little equation that I can solve. I add up my x's, 1x plus another 1x plus another 1x plus another 1x is 4x's. And when I add my constants, I'm going to get 12 equals 324. Subtract 12 from both sides, I get 4x equals 312. And when I perform division, x equals 78. Now, it didn't just say solve the equation, it said find 4 consecutive integers. So my first even integer is 78, my second one is 80, and then 82, and 84. And you can take a calculator and check that. The sum should be 324. 78, add 80, add 82, add 84. And notice that the sum is 324. So I can be sure that those are my 4 consecutive integers. Last on this part of the section are our literal equations. Literal equations is typically an equation that has a lot of letters. Okay, and you'll see this in science class. You know, equations that represent mass and volume and velocity and all that kind of stuff. And so, more often than not, it's easier to substitute into an expression if you can isolate or into an equation. So I'm going to solve for A. Excuse me. Notice A is over here. It's being multiplied with 2. The B is in the way. I've got to get rid of the B. The only way I can get rid of the B is an opposite operation. So instead of, here I see addition of B. To remove it, I'm going to subtract it. So the left side becomes P subtract B equals 2A. And because I like my variable that I'm solving for on the left, I'm just going to switch sides. And now I'm going to arrow over to show, to isolate A, I need to divide. And I need to divide this quantity by 2. So my A value is equal to the quantity P subtract B divided by 2. Okay, don't make these harder than what they seem. You're just doing the same old algebraic manipulation by doing opposite operations to isolate that variable by itself. Okay, notice in the next one it says solve for f. I need to get f by itself. This fraction is in the way. Fraction means divide, and what's the opposite of divide? Multiplication. So how do I get rid of a fraction then? I'm going to multiply both sides by the reciprocal of 5/9. The reciprocal of 5/9 is 9/5. So I get 9/5 times C on the left side, and I'm just gonna show it out. 9/5 times 5/9 times this quantity F subtract 32. And you see what happens is the 5s are going to divide out, the 9s are going to divide out, and this number now is a 1. I'm going to switch sides. F subtract 32 equals 9/5 being multiplied with C. And now the only thing left to do is to get rid of the 32. Notice it's being subtracted with F. And so to isolate it, I end up with 9/5 C add 32. So again, to get rid of that fraction, you multiply by the reciprocal. Last one, solve for x. Now, this one's a little bit different because I see x 2 times. You can't just take the b over and divide by a and say you're done. Excuse me. You've got to get the x's on both sides. Okay, so this needs to come over here. And then you might as well move the b over here with the d. Okay, so when I do that, I get ax subtract cx is equal to negative b subtract d. They're both negative. I put the b first because it's alphabetical. The only way to get the x out of these two terms is to factor it out. Okay, this is a GCF factoring, greatest common factor. These two terms have x in common. So I factor it out, and I'm left with a subtract c equals negative b subtract d. Now this is quantity, and I have to solve for x. So I'm going to divide this quantity by that quantity to get the x by itself. So my final answer here is negative b subtract d over a minus c. Now, if you don't like all these negatives here, you could factor a negative out, but that'll be for another time that we do that. I would accept this answer, but keep in mind, this negative belongs to b. You can't pull it out in the front here. It's got to be like this quantity, negative b minus d over quantity a minus c. So, let me know if you have any questions. You know, we could annotate this a little bit better and say, get x's on the same side. And then factor out the x. Because it's a GCF. And then you're going to divide quantities. So if that's a little bit confusing for you, then have a question either for the homework discussion or ask a question in class. This would be your homework, worksheet practice 1-3. These problems, I recommend you printing it out on Follow Me, or if you have a printer at home, print it out at home. If you don't, then just write the problems. You don't have to write all, everything. You don't have to copy the worksheet word for word. But I would like you to have the original problem and show your work if you're not going to print out the worksheet. And these are the problems that you're going to do for that homework assignment. Okay, see you next video. Have a great day.